Good morning, good afternoon, good evening, mammals. This video is for NTI day number 6, which should be Wednesday, March the 18th. What we're going to do today is, after watching some notes on effective nuclear charge, now we're going to be linking together effective nuclear charge and the first of our periodic trends, which you looked at, which was atomic radius. So we're going to be using effective nuclear charge to explain some changes that we see in atomic radius. So I'm going to make some comparisons here. Just like in the last notes video, I'm going to be making a horizontal comparison. So I'll be looking at sodium and argon, which are both in the third row. And then after that, we're going to make a vertical comparison. We're going to go down from sodium to potassium. So looking at the graphs that people were turning in, they were spot on. You guys picked up on this kind of shark tooth pattern where within each row, the atomic radius goes down, 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 down. And then when you start the next row on the periodic table, it spikes up and goes down again. So you got something here. The first row, it only has 2 elements in it, so you get 2 points. The second and the third row have 8 elements in it, so you get this longer trail down here. And I left the fourth row off. I didn't finish it all the way. The fourth row is the first one where we picked the D block up, so you notice that it was kind of extended out there. But what we can see is that as we go across in a row, the radius decreases. But then when we go down, it increases again and starts that same pattern. So we're going to use effective nuclear charge to explain it, especially the horizontal trend, because it's a little bit contradictory. What you would expect is, here's this sodium atom, 11 protons, 12 neutrons, 11 electrons, versus argon. It has more of everything. It has more protons, it has more neutrons, it has more electrons. Common sense would make you think that this is going to be a larger atom. However, it's not. Its radius is about half the size of the sodium's radius. And that's because it has a much higher effective nuclear charge, drawing these electrons in. And I won't completely re-go over why it has a higher effective nuclear charge. That's what the previous video was for. But basically it has the same amount of inner electrons providing repulsion. These 10 inner electrons here, they're the same as sodium's. But it has significantly more protons providing attraction. So it has a higher effective nuclear charge than sodium. So it draws its electrons in more tightly, making its radius smaller. As we go down, the opposite thing happens. As we go down, our effective nuclear charge is less, because now the valence electrons are in a more distant shell. Potassium has 4 shells, so it has 18 inner electrons instead of 10, which weakens its effective nuclear charge. So with a lower ENC, its electrons are less attracted, and so they float further out from the nucleus, and our atomic radius increases. This is why you get this spike that you observed at the start of every row. You go down, you add a new shell, that new shell now has more repulsion, and the radius increases. And then as you go across, you keep the same amount of repulsion, but you add protons, so the effective nuclear charge increases, making it smaller, and then you repeat this process in each row. So your assignment for me today is to use what I just went over and answer this question and this question. How does the effective nuclear charge, as it increases as you go right, explain that the atomic radius decreases? And then as you go down, how does effective nuclear charge decreasing as you go down explain why the atomic radius increases? So what we should notice here is that E and C goes up, atomic radius goes down. So where effective nuclear charge is high, then the atomic radius is small. And then the opposite is true down in this corner. So if you have any questions about that, I'll just be looking for your paraphrasing of this video to explain those two questions. Hit me up on Google Classroom. And as always, take care of yourself and others, practice good hygiene, and I'll see you on the flip side.